Today we'll be learning group 15 elements, the nitrogen family and its compounds, nitrogen and its compounds. We know in group 5, that is group 15 of periodic table, we have nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen is the most abundant element and we know the major proportion in air is nitrogen. It is nearly 80% of the atmosphere air, 20% is oxygen. So nitrogen is very vital, plays vital role in life also. For plants, it is the essential element. In our body also, nitrogen is the essential part. Now we shall see something about nitrates. It is group nitrites, we'll see. What is nitrogen? Nitrogen is non-metallic element of group 15. The periodic table, it's a colorless, odorless, tasteless gas. It is present in plenty in atmosphere. It is the constituent of all living matters. Let us go to our syllabus, that is nitrites. Nitrites of any class of chemical compounds in which nitrogen is combined with another element having similar or lower electronegativity. Remember, when we call carbides, the other element should have electronegativity less than or equal to carbon. When we say oxide, the electronegativity of other element should be less than oxygen. When we say nitrite, the electronegativity of the other element should be less than nitrogen. So here, what are lower electronegative element? Boron, silicon and some metals. They contain nitride ion, which is similar to carbide. Nitrite can be classified into three general categories, similarly as carbides: ionic, interstitial and covalent. Let us see the ionic carbides. How nitrites are prepared, let us see. There are many methods of preparation of nitrites. One is by direct reaction of element, usually calcium, nitrogen, they are directly reacting, or by through their compounds. You see here calcium nitride. In this reaction, barium nitrogen hydride, that is barium amine, when it is heated, we get barium nitride. Nitrites are also formed during surface hardening of steel objects. When ammonia is used in hardening of steel, and in that reaction also we get nitrates. For example, see this reaction, aluminum nitride, Al2O3 plus carbon and nitrogen, it gives aluminum nitride and carbon monoxide. They are prepared either by direct reaction between the metals or through their compounds. Types of nitrites, we have three types of nitrites: ionic nitrites, covalent nitrites and interstitial nitrites. So ionic nitrites, when we see, lithium is the only element which forms ionic nitride, is because it is the first alkali metal. It forms nitrates with the formula M3N. These compounds, which can be considered, they consist of cations and anion. Anion is nitrogen, cation is metal, N3 minus. So lithium L3N, the formula should be L3N. It undergo reaction with water. Lithium is here. Undergo hydrolysis reaction to produce ammonia and the metal hydroxide. That means very less electro. This magnesium also combines with nitrogen to form Mg3N2. It's also a beryllium nitride, magnesium nitride, lithium nitride are the examples of ionic nitride. When we call about ionic nitride, the bond between nitrogen and the metal should be ionic. So metals have low electronegativity, so they easily combine with alkali and alkaline earth metals. They are combining with nitrogen, forming ionic nitrides. L3N, M3, the formula will be M3N2. here M3N2, that is Mg3N2, Be3N2, like this. Next we'll see covalent interstitial. Yesterday I was telling in the last class that metals or many substances have some spaces between their atoms. In those atom spaces, if another element goes and accumulates, they are called interstitial. If nitrogen is going and taking the place between the atoms, it is called interstitial nitrides. The largest group of nitrides are the interstitial nitrides. Transition metals. Transition metals are famous. They have interspaces between the atoms. So, similar to interstitial carbides, nitrogen also accumulates into that place and form the nitrides. They are called interstitial nitrides. For example, see, this is a reaction. Here we have this. They are of the formula Mn, M2n, M4n, like this, depending upon the valency of the metal which we are using. For example, vanadium, vanadium, manganese, chromium, they form interstitial nitrides. So here they are chemically inert. They can tolerate high temperatures, hence they are used to make crucibles. Heating crucibles will be there. We heat some chemical compound in the lab in a crucible, and that are made up of interstitial nitrides. Next we have covalent nitrides. There are also a majority of the compounds, non-metals, they form covalent nitrides. Covalent, when we are talking about covalent, the electronegativity will not be very low. The other element, it will be nearly similar. So they possess wide range of this compound. Boron nitrides, sulfur nitrides are the best example. Let us learn about something. Carbon, nitrogen, cyanogen. Did you hear the name cyanogen? Cyanogen is Cn twice. C2N2 is cyanogen. S2N2 is disulfur dinitride, and boron also from Bn, boron nitride. So let us see something about boron nitride. So boron and nitrogen together contain same number of valence electrons. Boron is 1s2, 2s2, 2p1. Nitrogen 2s2, 2p3, that is nitrogen. But number of valence electron is 8, 2 are bonded. Carbon atom, boron nitride is said to be isoelectronic with elemental carbon. Boron carbide and boron nitride have similar electronic structure. Don't get confused. Boron and nitrogen belong to different groups. Boron belongs to third group, nitrogen belongs to fifth group. But boron nitride and boron carbide, it has similar structure. Same, the structure will be same as graphite and diamond. Hence, it's a very hard structure. You know, yesterday in the last class we have seen boron carbide is also known as carborundum. So this is boron nitride. Not go into so many details of this. Covalent carbide means you have to name cyanogens, boron nitrides, sulfur nitrides. Let us see what is cyanogen. Cyanogen is also a very important compound. Cyanogen. And let us give this title, cyanogens. Cyanogen is a toxic colorless gas that boils at minus 21 degrees centigrade. Cyanogen. It's a poisonous gas mainly used in refrigerations, all these things. It's a highly oxidizing gas. Cyanogen is a toxic gas. Oxidizing elements are toxic. It can be prepared by oxidation of hydrogen cyanide. A variety of oxidizing agents can be used. So here it is all this used to prepare this. Now it's peculiar structure, cyanogen. If you see C single bond C, and there are triple bonds to nitrogen. This is cyanogen. Flammable, it burns in oxygen to produce extremely hot flame about 4775 degrees centigrade. Very hot flame is produced by burning of cyanogen. It is burnt in rockets. It is also called rocket fuel. Remember, cyanogen. What is the formula? C2N2. That is the formula for cyanogen. This is a covalent nitride of nitrogen. Next you have this sulfur nitride. Covalent nitride, we are giving three examples: boron nitride, cyanogen, and sulfur nitride. Sulfur forms variety of binary covalent nitrides. Different oxidation states of sulfur, it forms different types of nitrides. For example, you see SNX, S4N4, S2N2, S6N6, like this different formula, it forms variety of these nitrides. So here in nitrogen family, the first thing we have to see is the nitrides. We know nitrides are the binary compounds of nitrogen along with the binary. Let us go to this slide. Nitrogen, class of chemical compound in which nitrogen is combined with the element of similar or lower electronegativity such as boron, silicon, and most of the metals. Nitrides contain N3 minus ion similar to carbides. They are divided into three categories. Let us sum up: ionic nitrides, covalent nitrides, interstitial nitrides. Ionic nitrides are formed by first group and second group metals. Only lithium forms because of smaller structure. Lithium is only forming lithium nitride. Magnesium nitride, boron, beryllium nitrides are other examples of ionic compounds. Next we have interstitial transition elements. We know they have good spaces between the atoms, and in those spaces, which are called interstitial spaces, nitrogen can be accommodated, and such nitrides are called interstitial nitrides. Next one is covalent nitride. We find so many variety of covalent nitrides with nonmetals, particularly sulfur, boron, carbon. Carbon nitrides C2N2 is called cyanogen, and we have cyanogen is a very highly toxic in nature and it is oxidizing in nature, hence it is used as rocket fuel. Cyanogen produces a flame whose temperature will be in maximum up to 4,000 degrees centigrade. Similarly, we have boron nitrides. It is the structure is similar to boron carbide and it is also a hardest substance. And boron nitride is used in the preparation of crucibles because of its inert nature. So go to this. We have in nitrogen hydroxyl amine. If you know this compound, hydroxyl amine is a very important reagent in the laboratory. It contains two groups, amine group and hydroxyl group. NH2 is amine group, OH is hydroxyl group. So it is called hydroxyl amine. Hydroxyl amine. Is it not? Hydroxyl amine. We are calling it as hydroxyl amine. Hydroxyl amine is an oxygenated derivative of ammonia used in the synthesis of oximes. Oximes means when aldehydes and ketones react with hydroxylamine, they form C double bond NOH compound that is called oxime. And these oximes, they are used in the manufacture of plastics, fibers, so many variety of medicines and photographic development of this. Nylon 66 is also made. Caprolactam, cyclohexane can be converted into, so there's some other polymers which are used in photographic development. So next, going that we don't need this thing. So today, in today's class and today's presentation, you have to remember the nitrides, types of nitrides, what is the importance of nitrogen, what are nitrides. Nitrides are the binary compounds of nitrogen with the elements, with other elements having equal or less electronegativity. In nitrides, nitrogen will be present in -3 oxidation state, and there are three types of nitrides: ionic nitrides, interstitial nitrides, covalent nitrides. Group 1 and 2 elements, lithium, magnesium, and beryllium, we have seen, they form ionic nitrides. And interstitial nitrides with most of the transition elements, vanadium, titanium, cobalt, nickel, copper, all these they form interstitial nitrides because transition elements have interstitial spaces between the atoms, and in those spaces, nitrogen can go and get accommodated. Hence, they form interstitial carbides. Interstitial carbides are hard substances. They are used as refractory materials. Next, we have covalent carbides. Non-metals like carbon, sulfur, boron, they form interstitial carbides. Covalent carbides, sorry. So cyanogen, C carbon, nitride of carbon, C2N2 is called cyanogen. It's a highly oxidizing and toxic material. It is used as a fuel in rockets and all these substances to produce high temperature. Where we need high temperature, cyanogen is used, C2N2. The temperature produced by the flame of cyanogen is nearly 4000 degrees centigrade. So next we have this compound hydroxylamine. Hydroxylamine is NH2, that is amine. OH is the hydroxyl group. It is prepared. How hydroxylamine? Hydroxylamine is used as a reagent in the lab. It is used for preparing so many polymers and different things. It is prepared by several methods. You see here, direct hydrogenation of reduction of nitric oxide. By using a catalyst, we can prepare hydroxylamine. It's a colorless crystalline solid, an unstable compound decomposing to nitric oxide and hydrogen. This is the back reaction. It is usually handled in the form of salts. So in today's class, that is group 15, we have learned about nitrides and hydroxylamine. In the next class, we will continue with this. So for today, it is thank you. So this is the end of our class. In the next class, we will learn something more about the group 15 element and other compounds of this group 15 elements.